So hey guys, welcome to this video, and in this video we're going to talk about hash tables. So why do we first use hash tables, right? We have arrays, we have linked lists, but the problem is that when you have to store a large number of data, like approximately 200, 300 strings you have to store in a array or a linked list, then almost the insertion, deletion, and the lookup time is almost big of n. Okay, so to reduce it, we use hash tables, and hash tables provide almost a really uh, constant time lookup. It's almost like big O of 1 in hash tables. Okay, so hash tables are 2D, like it uses 2D space, while a linked list and arrays use 1D space. So let me show you. Okay, so here we can see that uh, this is a linked list over here. Linked list, no, let's say an array or say linked list over here, which only uses 1D space, right? And here is hash table, which uses 2D space. Okay, so like if you want to store a large amount of data, let's say you have to say you have to insert apple over here, right? Over here, then you almost have big of n time to search apple or to insert apple. Okay, but in hash tables it's not like that. It's almost constant time lookup. Let's say you want to store hash apple, so apple, then let's say you have to store animal. So what you will do is we'll use chaining over here. So in hash tables, first of all, in hash tables we store we take an array and it stores the store pointers. Okay, and it will point to a particular linked list. So this is a array which is represented in vertical manner, and the linked lists are represented in horizontal manner, right? So what this a will do, a will point at the linked list and it will store all the elements which starts with a, but same with d, same with c. And so in general what we can say is, like, we have given another dimension to an array, and that other dimension is linked list, right? So let's say you have to store a particular string animal over here, right? So it almost gives you a constant time lookup and constant type insertion. So like if you have to search apple in this hash table, so what you have to do is, first of all, you have to go to the hash function and return that, okay, what is the value of apple that function returns. So it will return 0. So we'll go to this index, so we'll go to this index and array, and we'll see where it points. Okay, so like if it will see that apple is right over here, it is the first element. So like tada, it's just a constant time. If you want to search animal, it will go to a, then it will go to apple, and we'll see that if apple's next has that element stored in it. Yeah, we found animal. So it's almost three steps it took. First of all, we have to hash a function and see that at what index that function the pointer can be stored. Okay, so we'll come to a, then a will point to apple, apple will point to animal. So it's that simple in over here. So let's get back to the code. So in the code, what we have done in this project is, we have it's a sort of a college predictor where we have stored approximately 37 colleges, the information of 37 colleges, and you can see that the here it is, the structure of a college. We have stored strings. Okay, actually C don't have string as a data type, right? So we have just aliased it, right? We have type def and char star string. So we have that string now as a data type. Then this is to point at next node, and this is just another some details. Okay, so like what if you want to, in this program, what if you want to search any colleges? So we will use hash table for it. So we will so the time of searching it is reduced, almost constant. Okay, then these are some functions in our program. And first, these are all the information that are stored. So let's go all the cases one by one. So okay, let's say you want to store any college named DICT, right? So what this will what it will do is, no, first of all, let's go to the first of all, Okay, sorry. First of all, we have to load all the colleges in Hashtable. I have stored all the colleges data, but they are not pointing anywhere. Okay, they are just stored randomly in memory. So now I have to bring all of them into a hash table, right? Into the hash table, I have to bring it. So first of all, what we do is uh, we'll go over here in load function. It will take college as an input and boolean as an output. Is will be its output. And first of all, we will store an integer index. We will declare an index, and what we'll store is the hash, the integer that is returned to us by hash function. So what hash function will do is it will take a string as an input and int as an output. Okay, so it will take the first letter of that string. It will to lower it, means it is a function. It will lower that first letter of the string and will deduct the ASCII value of a from that character, right? So like we have ASCII value for all the characters. Okay, so like let's say DICT is the input. Okay, so it's the first letter is big D. It will convert it to small d. And what is the ASCII value of small d? We can see over here. ASCII value of small d is 100. Okay, so 100, and we will minus it from the ASCII value of small a, which is 97, which is 97. Okay, where is it? Where it is? Here. So what we'll get is 3. Hence, at the index we got is 3. So for any college name that starts with D, it will go to the hash table's index 3 only. Okay, and then we will see that if the index of the table, so is that index of the table pointing somewhere? If it's null, then it will point at this college, which we just gave as an input, right? So if it is not pointing to anywhere, it will point to this college. But if it is pointing to someone, then we have to use this else case, and it will be much more clear in the paint. So let me switch to paint. Okay, so there we saw that we want to store DICT, right? So what it will do is we saw that hash function returned 3. Okay, so it will go to this 3 index. It will see that okay, it is pointing to no one. So here we'll store DICT. Okay, so now let's say that we have to store another element, another string which whose name starts with D as well. So let's say I want to store DDU, another college in Gujarat. So I want to store DDU. So what it will do is first it will make DDU point towards DICT, right? It will take this node and it will make it point wherever the head, like wherever this the index of this hash table is pointing. So index of hash table is pointing at DICT, right? So it will point at DICT first. So it will point at DICT first, and then the index of this hash table will be made to point towards DDU. So we are not inserting at the back of DICT, instead we are inserting at front. And the bonus point of this is because if we are inserting at the back, then we have to go at like big O of n times. But inserting at front is almost constant. So that's why we are inserting like this. And let me adjust some of the pointers. So this will point over here now, and this will point here. So that's what our load function is. It will load everything like this. Okay. Okay, so now we have seen the hash function, we have seen the load function. So now it may be clear to you. You can see that okay, we are taking an index. If it is pointing to nowhere, the head will the index of that point hash table will point to this college which we just uploaded. But if it is already pointing to somewhere, what we'll do is the college we just inserted will point at the point where the index of the table is pointing. Okay, we saw in that paint in the MS Paint, right? You can rewind the video and see that how that worked. So the college we just inserted will point wherever the table index of the table is pointing, and then the table of that index will point at the newly pointed college. Okay, so in this way information is not lost, and then we'll return true. And there is another function, int rank predict. It is just a normal basic function to predict the rank, and what it will do is it will take science percentile from you. It will take good set percentile from you. If you don't know how this works, it's just a process to get rank in Gujarat, like ACPC rank. So it will take both of this percentile. It will multiply zero point 0.6 to it and zero point 0.4 to it. It is just a process, just a formula of how to calculate rank in Gujarat. You can use anything that works over your place, and what it will do is minus the like you will get some total percentile as total percentile. Suppose you have 98 as total percentile, so it will 98 would be minus from 100, and 36216 is the number of students that appeared in that exam, and divide by 100, so you will get your total rank over here. So that's what this function does. So let's go above. Here we have just stored all the data about colleges, and here we have opened a file for appending, and you will see why we have done that. And I have used do while loop everywhere, just because like suppose like uh, I inputted 4, but our function only takes 3, 1, 2 or 3. So if anyone inputs 4, my function will again tell him to input from 1, 2 or 3 only. So I have used multiple do while loops, and this is just to make everything beautiful. Okay, okay, this is also do while loop. Like I told you, if you will input anything less than 1 or greater than 3, it will tell you to input again. And this is the normal switch case, and you can see that I have loaded all my colleges over here. In this load function, it will load all 37 colleges, and this is just a string to store the college name that the user just inputted. And this will be okay. So like, okay, user inputted a college name. Now I want to give him the information about that college. So what num1 will store will the hash function of that, the hash of that college. Okay, so if that college starts with let's say PDEU. Okay, so what it will store is the whatever the hash function will return. It will obviously return the index where all the college name whose name start with P will store. Okay, so int jk, this is the college head where it will be pointing like at all the indexes that stores the name P. Okay, this is int jk. It's just an int that I have declared for further use. It's type of flag. So if you are not getting any college that we don't have stored in our system, so it will we will take that and store in feedback.txt. You will see it further. And this is just a for loop to find the number which will match with our index. If we don't use this, it's also okay. I have just used it over here just to showcase you that this for loop is not really necessary right over here. Without this for loop, our work will also be done. So for that I have used this for loop. Let me comment it out. Without this for loop we will also be good. Okay, so now we don't have to go and search through all the elements of an array. We'll just use a hash function which will return as an int, and then our head we declared a new college star head over here, which will point at all the nodes that which will point at all the nodes that the input college was. So like input college was PDU, so whatever will be wherever the P will be located in that hash table, it will point to the all the college name would start whose name starts with P. Okay, so we'll take the cursor, and when till this cursor, okay, we have declared a cursor over here which is equals to head, and while this cursor is not equals to null, cursor will be incremented to cursor.next. So let me show you how this works. Let's say that index number, I don't know, A B C D F G, wherever P comes, let's say 22. So at index number 22, P will be stored, and let's say P first points at parul, then it points towards I don't know, whatever P something, that it will point towards uh, another college name starting with P and Panku, let's say, whatever, and then it will point toward PDU. Okay, and PDU will point toward null. Okay, so it's not really pointing towards anything. This is the last element. Okay, so what it will do, what will this cursor do is, what this cursor will do is, first it will point wherever the index of this hash table is pointing. It is pointing towards parallel. Okay, so we'll first see if star case compare. Star case compare is function. What it does is it compares the two strings without case, like whatever their case may be, like big diacity or small diacity. If there is any case sensitivity, it will just remove that. It will not see like bada hai ya chota hai, a b c d. It will just compare those strings, and if that string is equals to, if this value is equals to 0, means that both strings were equal, and we will print all the details. Okay, so let's say uh, first of all we are pointing at the head parallel. So parallel doesn't match with PDU, right? So its cursor will be incremented to next. So next points at whatever this is, and this is also not PDU. So cursor will be incremented and it will point towards Panku, and Panko is also not the college we wanted. So what it will do is it will increment it to PDU. Okay, so PDU is the college we wanted. So what it will do is star case compare college name, it will be PDU, and cursor name is also PDU. So it will print out all the details that are there of PDU, like whatever that hostel accommodations, fees and all. And we will increment our flag over here. So just we can come to know that okay, we have found the detail of college we wanted to find. But if flag is equals to 0, means we have not found the college. So what we'll do is we'll print it in the feedback.txt file, the college name, because like it's a good thing, like your professor will also be happy seeing this, like okay, you have took the feedback from the user, and it just states that sorry, we are currently under beta version, we will soon add the information regarding this college. And this is just case 2. Over here what we have done is we have take the rank as an input from the user, and we will show them the colleges that he might get. So colleges you might get over here. So this is just to store all the colleges. And if your rank, suppose your rank is let's say your rank is 1200, so every college whose rank is greater than 1200, okay, whose rank is greater than 1200, so like college with rank 1500, college with rank 3000, will be stored in this array predict array, and we will just show the user that okay, these are the colleges you will get. And then if he enters, like suppose at number 2, like best colleges he get, okay, so like if his rank is 1200 and the closest college he can get is of 1500, so first it will be 1500, second will be 3000 named college. So let's say if he wants to uh, data of 1500 college, so he will enter 1 and he will get all the data. And this is just the case 3 that I shown you over here, the rank predict. This is just the case 3. So, and okay, at last we also have to unload all the hash table, like we have to free those memory, right? So what it does is it takes college head points at table index 0, and till head is not null, we just free all the nodes from that hash table. So how this will work is uh, let's say at 0 we have a, it points at AU, Ahmedabad University, AIT, and any other thing, let's say Arami. So what it will do is it will create another pointer named TMP, and TMP will be pointing towards head ka next. So head's next means head is AU and AU ka next is AIT. So TMP will be pointing toward AIT, and then we will free this AIT, free this AU. Sorry. TMP will be pointing towards AIT. We will free this AU, and then we will make the head of this table points toward TMP, and TMP is pointing towards AIT. So what it will do is, what this does is, TMP will store AIT in it. We will free this head, means we will free this head, and we will make head points towards TMP. Okay, so head will point over TMP, and TMP is pointing towards AIT, means indirectly we can say that head is pointing towards AIT. So by this way we will unload our hash table. So let's see all this in working. Make chunk, that's a pretty bad name to give to a file. Okay, it's compiling. Dot slash chunk. Okay, sorry, dot slash chunk. Okay, so it says welcome to project college. So what do we want to do? So I would say that I want college detail over here. Like the do while loop was for this. Let's say I input 5. Okay, so it will tell me again to input again give any number which is from 1 to 3. Okay, so let's say I want college details. Whose college detail I want to get? I will write any random. Uh, let's say IITM. Okay, IITM is not in our we have not loaded in our hash table, so sorry, we are currently under beta version, and soon we will have this information regarding this college. Okay, I exit and see if IITM is stored. Okay, you can see IITM is stored over here in this txt file. Okay, let's run again. Oh my god. Okay, college detail. Whose college detail I want to get? I want to get the detail of PDEU. So here I got every detail about my college, PDEU itself, finance, and etc. Okay. Oh my god. Let's run it again. Now I want to see college predictor. I have to enter my rank. My rank is, let's say, 7. So these are all the colleges that I'll get: DICT, NIRMA, MSU, DDU, Indus, PDU, etc. Now let's say I want to have information about Nirma college. So I will enter 2 over here, and I will get all the details about Nirma. Okay, so I want to run again my program, so I'll enter 1. Now I will go to rank predictor. My science board percentile is 97.66. My good set percentile is 99.48. So my approximated rank is 583. This is what it tells. So these were all the use case of our nice cute little project using hash tables. Thank you. And by the way, I am Jay.